In-memory technology was first introduced in SQL Server 2012, and they're built into the SQL database engine. They can improve performance significantly for workloads such as data ingestion, data load, and analytical queries. Azure SQL Database in-memory technologies are only available on the Premium Service tier. Azure Database has the following in-memory technologies: in-memory OLTP and column store index. And let's talk about these briefly. So, as the name suggests, in-memory OLTP improves performance for transaction processing scenarios where the major portion of the workload consists of inserts, updates, and deletes. And in-memory OLTP, or online transaction processing, is achieved by using one of the following objectives: memory optimized tables, natively compiled stored procedures. Now, memory optimized tables are used to store data in memory. All of the data in a memory optimized table resides in memory. Memory optimized tables and disk-based tables can reside within the same database simultaneously. Now, a table is defined as being memory optimized table at the time of creation. So a memory optimized table script will contain tags or contain code that will enable the memory optimization. And you can see that in this snippet of code here. So we've got a create table, we've got our table definition, and then we've got with memory optimized on, durability, schema, and data. The memory optimized keyword specifies whether or not the table is a memory optimized table. Durability refers to retaining only schema or schema and data for the memory optimized table. The table's in memory, the data will go out of memory if the machine gets restarted or rebooted. However, if durability is set to schema and data, SQL Server will make sure data isn't lost. Now, natively compiled stored procedures. A regular stored procedure is compiled and the plan is cached within SQL Server. A natively compiled stored procedure is compiled into a DLL and then loaded into memory, and this further improves the data manipulation command performance on memory optimized tables. Now, a natively compiled procedure syntax looks something similar to what you can see on here. So we've got create procedure, insert customer order with natively compiled, schema bind, and execute as owner. A natively compiled procedure contains the regular T-SQL code as the inter-OP or regular procedure. However, it's defined differently at the time of creation. The term native compilation defines that the procedure is a natively compiled procedure and is to be compiled into a DLL. A natively compiled procedure should be schema bound and should have the execution context. Natively compiled procedure is always executed in a snapshot transaction isolation level, and memory optimized tables and natively compiled procedures, which together can speed up an OLTP transaction database workload and make it up to 20 times faster. Other memory technologies include column store indexes. Now, these were introduced in SQL Server 2012. You could have a non-clustered column store index in SQL Server 2012, and they use columnar storage instead of regular row-based storage. A row store has rows with multiple columns arranged sequentially on a page. With a column store, the values of a single column, which from different rows, so columns from different rows, are stored contiguously. Column store indexes were added to in SQL Server 2014. Okay, so you can potentially have a clustered index on a column store index in SQL Server 2014. So they've been improved in SQL Server 2014. But with a row store, this is how data is stored on disk. So we've got columns from different rows. Okay, in a row store. In a column store, the same information will get stored as the columns on a page where they're stored contiguously. So we get all the first names, all the professions, and then the states where they live. Column store has got better compression compared to row store, as values of the same data type compress better than values of different data types. Okay, so with a row store you get different data types. This improves query performance as only those pages which contain the selected column values are scanned and fetched, therefore reducing the number of reads. So consider the following query. We'll select name and profession from employees. This query will only touch pages with the name and profession column if it's run against a column store. If it's run against a row store, the query will run through all the pages. So this is going to significantly improve the performance in a data warehouse scenario with huge tables. We can have clustered column store indexes that store the entire table data as a column store. They reduce the storage footprint of the table by up to 10 times its original size. They can be used on fact tables in a data warehouse to speed up queries and fit more data into the available storage. And then we've got the syntax for creating a column store index here. So it's create clustered column store index, provide the name on sales orders, and that will create a clustered column store index for us. Non-clustered column store indexes are created on sets of table columns and can coexist. Okay? When they were introduced in SQL Server 2012, a non-clustered column store index, if it was created on a table, the tables weren't updatable. Okay, so if you had one on a table, you weren't able to do any sort of data updates on that table. Now, starting in SQL Server 2012, they are now updatable and can be used to gain real-time operational insight into your transactional data. So whereas in 2012, you need to load the data in, create the index, and run your select queries against it, in SQL Server 2016, because they're updatable, you can really do real-time analytics against your database. You can query the operational data directly instead of spending time doing ETL, loading the data into a warehouse, and then creating the column store index. You can do this without impacting your operations at all. So the syntax for creating a column store index is as follows. Create non-clustered column store index, specify the name on sales, and then specify the columns you want to include. Now this query creates a column store index on customer ID, contact person ID, and order date. And the column store structure is stored separately from the table structure.